Hi guys, today we're going to talk about the properties of exponents, specifically multiplying and dividing monomials. And a monomial is an algebraic expression with one term. So, the I can statement we're working on today is I can simplify exponential expressions using the properties of exponents. And we're going to really focus on the properties of exponents. And this video is going to be a little different because I'm going to work through a few problems with you, and in the summary section of your notes, you're going to need to give a rule for the examples based on the patterns you noticed. Give a rule for the examples that I show you in the video. So let's get started. So what does this expression really mean? If I had 5 to the third power times 5 to the fourth power. Well, we know, using the order of operations, in order to solve this, we would need to first do the exponents, take care of those exponents before we multiply. So if we did that, we'd really be taking 5 to the third power, which is 5 times 5 times 5, and multiplying that by 5 to the fourth power, 5 times 5 times 5 times 5. And we're going to be multiplying those together. Now, I don't want to work that all out, and I'm sure you don't want to as well. And you can't use your calculators. So, is there a way I can simplify this or write this in a better way where I don't have to work out all of the multiplication? Well, we know multiplication is commutative. So, I don't have to do 5 to the third power and then 5 to the fourth power since it's all multiplying anyways. I can look at this big long expression of 5s and turn that into an exponent. So 5 to the third power times 5 to the fourth power, I'm multiplying a bunch of 5s, so I've got 1, 2, 3, 4, 5, 6, 7 5s, so that would equal 5 to the seventh power. So that tells me that 5 to the third power times 5 to the fourth power is actually 5 to the seventh power. Note 5 to the third power times 5 to the fourth. How is that related to 5 to the seventh power? Think about that, and let's try another example and see if your thoughts apply to the next problem. So now let's look at 3 to the fifth power times 3 to the fourth power. Well, if I were to expand that, I'd have 3 times 3 times 3 times 3 times 3, so I'd have to write it out 5 times. And 5 to the fourth power, I'd have to write the 3 4 times and multiply that. And if I multiplied both and I wanted to simplify this expression, I can 1, 2, 3, 4, 5, 6, 7, 8, 9. I count my 3s, there's 9 of them. And so my answer would be 3 to the ninth power. So 3 to the fifth times 3 to the fourth is actually 3 to the ninth. Think about this. What happens to my exponents when I multiply these monomials, and what happens to the base? So from these two examples, we can draw a conclusion. In the summary section of your WSQ, explain how we simplify monomials when we are multiplying them if they have the same base. Pause the video and write your rule in the summary portion. Then hit play. Now, we're going to talk about dividing monomials. But before we do that, let's look at what it means to simplify a fraction. And let's look at the fraction 10/12. Now, to simplify this fraction, I know you already have the answer in your heads. You would have to divide the 10 by 2. And divide 12 by 2 to get 5/6. But let's look at 10/12 again. Another way to write 10 is 5 times 2. And another way to write 12 is 6 times 2. So when I go to simplify 10/12, what I'm really doing is eliminating a 1, which is 2 over 2. So I notice that there are common factors in 10 and 12, and I can eliminate that common factor by really just dividing by 1, because 2 over 2 is actually 1. So let's look at that and let's apply that to dividing monomials. So let's look at what this expression, 5/6 divided by 5 to the 6th power divided by 5 to the 3rd power, let's look at what that really means. Well, if I were dividing it, and now remember, another way to write this would be 5 to the 6th over 5 to the 3rd. That's just another way to write a division problem. So if I wrote that out in expanded form, I would have 1, 2, 3, 4, 5, 6 5s on top, all being multiplied, and 1, 2, 3 5s on the bottom, all being multiplied. Now I can cancel any common factors in the numerator and denominator, just like when I'm simplifying a fraction. And when I do that, I actually have canceled all of the 5s in my denominator, so that's really a 1. And so I get 5 to the 3rd power over 1, but I don't need to write that 1 at the bottom. So 5 to the 6th power divided by 5 to the 3rd power is 5 to the 3rd power. Take note again of what happened to the bases when I divided and what happened to the exponents. And let's look at another example. How about 4 to the 7th power divided by 4 to the 2nd power? And remember, another way to write this is 4 to the 7th power over 4 to the 2nd power. And if I put that in expanded form, I would have 1, 2, 3, 4, 5, 6, 7 4s in the numerator, all being multiplied, and 4 times 4 in the denominator. And again, just like when I simplify fractions, let's cancel the common factors in the numerator and denominator. Again, I notice I've canceled everything in the denominator. So really that's like having a 1 in the denominator. And so I look at my numerator and I notice there's 1, 2, 3, 4, 5 4s on top, all being multiplied. So when I'm actually dividing 4 to the 7th power divided by 4 to the 2nd power, I get 4 to the 5th power. Again, notice what happened to my base. Notice what happened to my exponents when I was dividing these monomials. Here's a different example. 2 to the 3rd power divided by 2 to the 5th power. And let's look at that if I write it as a fraction. Looking at this problem here, I notice right away that the number in the numerator is actually going to be smaller because 2 to the 3rd power is going to work out to be a smaller number than 2 to the 5th power. So let's see how that affects how I solve this problem. Well, let's write the numerator and denominator out in expanded form. I have 2 times 2 times 2, 2 to the 3rd power, and 1, 2, 3, 4, 5 2's being multiplied in the denominator. Let's cancel the common factors. This time, I have canceled all of the factors in my numerator, and I know that that leaves that numerator as a 1. So what I really have here is a 1 over 2 times 2, or 1 over 2 to the 2nd power. This might contradict what you were thinking as your rule for dividing monomials. But let's rewrite 1 over 2 to the 2nd power so it is not a fraction anymore. And remember, if I want to get that exponent out of the denominator and move it to the numerator, what happens to the exponent? It becomes negative. Remember, when I take the reciprocal of an exponent, I need to switch the sign of that exponent. So 2 to the 3rd power divided by 2 to the 5th power actually gives me 2 to the negative 2 power. Again, note what happened to the bases, what happened to the exponents when I wanted to work out 2 to the 3rd power divided by 2 to the 5th power. From these 3 examples, we can draw some conclusions. Look at the patterns, and in the summary portion of your WSQ, write a rule for dividing monomials. Pause the video And when you're done writing your rule, hit play. We have one more property to look at. So let's look at 5 to the third power raised to the second power and ask ourselves, what does this expression really mean? Well, if I had something like 5 to the fifth power, that would tell me to multiply 5 times 5 times 5 times 5 times 5. Okay, so that exponent's telling me how many times to multiply my base. If I have a 2 as my exponent out here, and everything inside this parentheses is being raised to the second power, that means I need to repeat, or my base now is 5 to the third power, and I need to repeat that 2 times. So really this is saying 5 to the third power times 5 to the third power. Now look back in your summary, how do I multiply monomials? If I want to take 5 to the third power times 5 to the third power, I would work it out 5 times 5 times 5 to represent this 5 to the third power, and 5 times 5 times 5 to represent this 5 to the third power, and multiply the two together, which would give me 5 to the sixth power. Therefore, 5 to the third power raised to the second power equals 5 to the sixth power. Note, what happened to your base and what happened to your exponents in this problem? And let's look at another example. How about 5 to the third power raised to the fourth power? This is telling me that everything inside these parentheses is being raised to the fourth power and therefore needs to be multiplied by itself 4 times. So, I would take 3 to the second power times 3 to the second power times 3 to the second power times 3 to the second power 4 times, because it's all of that is being raised to the fourth power. Once again, I'm simply multiplying monomials here once I've written it out. So, let's expand this. Each of these 3 to the second powers needs to be written out as 3 times 3. So, 3 times 3 takes care of this one. 3 times 3 here takes care of this exponent. 3 times 3 here takes care of this exponent, and 3 times 3 here takes care of this exponent. Note, I am multiplying them all together because when I raise something to a power, that tells me, or the exponent tells me how many times I need to multiply that base. So let's take this big long stream of 3's that are being multiplied together and turn it into an exponent, or exponential form. When I do that, I get 3 to the 8th power, and therefore 3 squared raised to the 4th power equals 3 to the 8th power. Note, what happened to your base? What happened to your exponents? And looking at these two examples, let's draw some conclusions. In the summary portion of your WSQ, explain a rule for raising an exponent to a power. Pause the video and write your rule. When you're done, hit play and we'll do some practice. Okay, it's practice time. You're going to have 3 slides given to you. So when you finish the first slide, when you get to the next slide, you're going to want to hit pause. Do the work in the work section of your WSQ, then hit play. Do the work on the second slide in your in the work section of your WSQ, and hit play one more time and do those problems in the work section of your WSQ. Altogether, you will have 15 problems. Pause the video now and complete numbers 1 through 5 in the work section of your WSQ. We are done with this lesson. So, when you are done completing 11 through 15 here in the work section of your WSQ, don't forget to write a question at the end. You may go back and watch any portion of this video as many times as you need to, or the entire video.